So today we are going to start with the chapter chemical reactions and equations. Okay. So we have gone through the basics. We have brushed the things which are required for this year. Okay. So after that, now we'll be starting with the chapter. So this is the first chapter from your chemistry part. So that is chemical reactions and equations. Okay. So what are the daily situations you see? Okay, I want the answers from you all. Now, see, so these are some of the reactions, chemical reactions, which goes on in your day-to-day life. Okay, so these are the situations which carry on day-to-day life. So the first situation is when the milk is left at room temperature during summers. What happens? Okay, milk is left. So when you leave your milk, okay, at room temperature during summers, what will happen to milk? If you keep milk open, okay, it is left open at room temperature. Room temperature means at your regular temperature, okay, not in the fridge nor this. Okay, so at the regular temperature, if you keep the milk left at room temperature during summers, what will happen during summers if you keep the milk open?
Ma'am, it will get spoiled.
Yes. See, so when the milk is left open, okay, at room temperature, what will happen? So what is present in the surrounding? Air is present, right? Air means what? Oxygen. Oxygen is present. So when oxidation is present, what will happen? Oxidation takes place. What do you mean by oxidation? Oxidation means when oxygen, okay, when anything that is oxygen which is present in the air, it reacts. Okay, it reacts, then it is called as oxidation. So milk is left open. Okay, milk is left open. So whatever the air or oxygen which is present in the surrounding, it reacts. Okay, it reacts, and there will be so the milk, it reacts with the oxygen which is present in the surrounding. And what happens? The growth of microorganisms. So microorganism takes place. Okay, and what happens to the milk? Milk gets sour. Okay, it gets sour. Right, so milk gets sour. So because of this oxidation, when it takes place, so while the milk is left open during summer, okay, so what happens to milk? It becomes sour. So this is the reason. So this what is happening initially? So is the initial situation and the final situation same? The milk is same. Is the milk same? No, right? There is something which is changing the milk, right? So first the milk, okay, at room temperature, it will be proper. So after keeping the milk at room temperature for longer time, what will happen? The oxygen which is present in the surrounding, it reacts. Okay, it reacts with the milk, and what happens? Oxidation takes place. Okay, oxidation takes place, and what happens? Microorganism. Okay, microorganisms, what the growth of microorganism takes place, and it results into a milk which is sour, right? So so milk, it gets spoiled. Right. So, so like this, what happens? So the initial state and the final state is not same. So what is happening here? So there is some chemical reaction which is occurring. So this is the first example, which is occurring in your day-to-day life. Then second example, an iron tawa, okay, pan, okay, or a pan, iron, this tawa or a pan. Okay, you make dosa, chapatis, right? That iron tawa. So that the nail, okay, nail. So which is left exposed to humid atmosphere. Humid atmosphere means during rainy season. Okay, during rainy season, how will be the atmosphere? Like that. Okay, so whenever you are keeping an iron tawa, then your pan, a nail, okay, which is left exposed to humid atmosphere. Okay, what will happen? What will happen to this situation? Yes. What
It
will
will
happen
get,
during humid atmosphere?
ma'am, it will get
If you
rusted.
keep a iron tawa open to air, okay, or to oxygen, what will happen? It will get rust, right? It will get rust. Okay, now you know your gates, okay, the gates in front of your home, okay, if you don't paint them, okay, what will happen? It will get rusted, right? Because continuously in rainy season or during winter, what will, due to humid atmosphere, okay, due to humid atmosphere, what will happen? It will the iron, okay, iron starts getting rusted. okay, due to the oxygen which is present in the atmosphere. So oxygen which is present in the atmosphere, what happens? It reacts with the iron. Okay, oxygen which is present in the atmosphere, what happens? It reacts with the iron. Okay, in the presence of the moisture. Moisture means what? Water. Moisture is nothing but water or the moisture or the water vapor, right? So in during humid atmosphere, that is during the winters or rainy season, what happens? So in atmosphere, the water vapors will be present, right? The moisture will be present, and what will be present? Oxygen will be present. So this, it reacts with the iron, okay? And what it forms? So when the iron, it reacts with the water vapor, oxygen or the moisture, so there will be a reddish brown coating. A reddish brown coating will be occurred on the iron surface, okay? And this is called as the, so it forms what? It forms a oxide layer. It forms a oxide layer on the your iron this, okay, pan. So this is called as rust. This is called as rusting. Rusting of iron. Rusting of iron means what? When you keep your iron open to air, okay, in air during humid atmosphere, there will be presence of moisture also. So air, okay, that is oxygen, then moisture. When it reacts with your tawa, that is iron tawa, it forms a oxide layer on the tawa, okay? So that it forms a reddish brown color. So that is nothing but your rusting of iron, okay? So when, and so even the nail, okay, nail. So when an iron nail is left exposed to the humid atmosphere, so it also, what happens? There will be rusting. Okay, there will be rusting. So the initially the iron which is taken, and later when it reacts with the, when it is exposed to humid atmosphere, is the iron at the initial stage and the final stage similar? No, right? So when the iron is exposed to oxygen or the moisture which is present in the air, what happens? The iron is getting an oxide layer. That is, it is occurring a rust. So there will be rusting. So rusting is occurring. So there is something which is happening to the iron, right? So there is some chemical reactions which are occurring on the iron. So this is the second example. Then next is grapes. Okay, you know grapes. So they grapes get fermented. Okay, what do you mean by grapes get fermented? Okay, what is done? Ripe grapes. Okay, ripe grapes. Ripe grapes, what is done? They are taken and they are kept in a closed jar. Jar is taken. Okay, you keep your ripe grapes in that and you close the jar. Okay, so what happened? Yeast develop on them, and as a skin. So what happens? So there will be some fermentation. Okay, there will be some fermentation if you close. If you close the, what is that, grapes into the closed jar, so there will be some fermentation occurring. So yeast will develop on them. Okay, yeast is also a type of microbial situation. Okay, microbial microbe. So yeast will develop on them, and what will happen? The skin of the grape, okay, will be broken, and this process of fermentation, it begins. So uh, uh, okay, till when this process starts, okay, till the sugar, okay, whatever the sugar is present in the grapes, okay, is turned into alcohol. So grapes are used in processing fermentation of wine and all, right? Fermentation of wine, then your jams. Okay, so grapes are used in fermentation of wine, then jams. So what is the process here? What they are doing? So grapes, they are kept in a closed jar. Okay, after keeping it in the closed jar, so there will be some yeast developed on that. So till all the sugar gets reduced into alcohol, the grape, it goes on fermenting. Okay, so there is a process called a fermentation. So is the situation same? No. So the initially and the finally, okay, the grapes. So there is some chemical reaction which is occurring. So this is another example for the chemical reaction. Okay. The next is food is cooked. Okay. Now, what happens to food? Okay, what happens to food? Initially, what happens to food? Yes, food is cooked. Now, food, it will be in raw, right? A raw material, rice, right? It will be raw. Your wheat will be raw, right? Your dal, pulses will be raw. So they are in raw situation. Later, after cooking. So is the initial and the final state. So after cooking, only you will eat. Will you eat dry rice, dry pulses? No, right? So you will be what? You will be cooking it and then you are having. So this is some process, right? So there is some chemical reaction. So rice, so what you do, you steam it, right? Rice, after steaming only you will have it. So like this. So this is also some chemical reaction which is occurring when in your day-to-day life. So these are some of the examples which are occurring in your day-to-day life. Okay, so food which is cooked, so that is also undergoing a chemical reaction. Okay, then food get digested in our body. So this is also a good example for chemical reactions which is occurring. Now when you have food, okay, how it is getting digested. So when you take uh, a bite of food, what you start doing, you start chewing it. Okay, you start chewing it. So when you're chewing, so there is a this, okay, what is there present? Saliva. So, right, saliva is a digestive enzyme. So what it will do, so it helps to break down your food, what you are chewing, right? So saliva, it helps to break down your, it is an enzyme which breaks down your food, right? So it helps to uh, swallow the food. Okay, so what happens? So first you begin to achieve the food in the mouth, and where it goes to your food pipe, right? Then it goes to your esophagus, and then to your stomach. Then finally from the small intestine. Okay, so as the food passes through the your tract, okay, or it mixes with the all the whatever in the digestive system, your this enzymes are present, okay, digestive juices are present. So your food, which is large complex molecule, okay, it gets broken into smaller molecules with the help of the different digestive juices. Okay, so this is the process how your food is getting digested in your body. So this is also some kind of chemical reaction which is occurring in your digestion. Okay, when you're having your food, so there is something digestion, okay, it is getting digested in our body. So this is also an example of chemical reaction. Then we respire. All right, we respire means what? We take in the oxygen. So what is this? This is also a chemical reaction, right? So we taking oxygen, we give we inhale oxygen, we'll exhale what? Carbon dioxide. Inhaling oxygen, from where we get oxygen? Plants produce oxygen, right? Plants, when they're producing their own food, right? So what they do, they produce oxygen, and intake, what they'll take carbon dioxide from us, right? So this is a example for chemical reaction. Understood these situations. So these situations we are seeing in day-to-day life. Understood the chemical reactions, right? All the examples. So these are some of the chemical reactions which occurs in our day-to-day life. Okay, so these are the situations, the day-to-day situations which we see. So what is chemical reaction? Okay, the initial state and the final state is the same? No, there is something which is occurring in between. Okay, so we'll just start with the, so okay, so what is chemical reaction? The process in which new substances formed, right? So the process in which the new substance is formed with the new physical and chemical properties is called chemical change or chemical reaction, right? Now milk, we had taken example of milk. So the milk which was at the initial stage and the milk which we got after oxidation is the same? No, it has some different physical and chemical properties. Okay, so the milk which is formed later is a new substance, right? It has undergone some chemical change. So there is some change in the physical and chemical properties. What do you mean by physical? The appearance. Okay, the appearance. Now you know milk, if you don't okay, during summer, if you don't boil it, the milk will get spoiled. Okay, it forms a curdy like layer, right? It forms a curdy layer, so that only it results into the taste. So milk first, it will be having, okay, it will not have that taste, okay, milk. So, but after it becomes, if it if it shows a sour taste, okay, it tastes sour, right? So there is some physical and chemical change which is occurring. So this, okay, this is called as chemical reaction. So the process which is obtained, okay, the process in which new substance is formed with new physical and chemical properties is called as chemical change or chemical reactions. So this is the meaning of chemical reaction. So whichever the so we have seen the day-to-day examples. So we have taken the example of milk, right? So this the substance, okay, so during this process, so it is undergoing some chemical change. So chemical reaction, it involves a change in physical and chemical properties. Like, now what do you mean by physical properties? Physical properties means which we can see. Which we can see means what is the taste, what is the color, what is the smell, okay, okay, what is the density, what is the it's this, okay, boiling point, melting point. These are some physical changes. Physical changes means which we can determine. Chemical properties means how it reacts, okay, how it reacts with air, how it reacts with water, okay. So these are the chemical properties. So chemical reactions means what? It involves some change, okay. Something is getting changed from an initial state, it is getting changed to a final state. So there is something which is getting changed. So first is what? So what are the different physical and chemical properties? The first in change in the color of the substance. Now, for example, iron, okay, iron, you know the color of the iron, okay. So iron first, so iron, it will be like steel color, okay. So if you take a pure this, it will be like a light brown color, maybe, okay, maybe so it will be a light brown color. So but when you what you do, when you expose it to air or oxidation of it undergoes oxidation, it turns brown, it forms reddish brown, okay. Means what? So you understand there is some chemical change which is occurring, okay. When you see some substance and you can see the initial color and the final color, and you understand, so there is something which has occurred. Means what? There is something, so something chemical change has been occurred. So how you will understand that a chemical reaction has been taken place? So the first is change in color of the substance. So if you make out there is a change in the color of the substance, that means some chemical change has been taken place. Then change in the state of a substance. Change in the state of the substance. State means what? A solid state, liquid state, gaseous state, okay, like that. Now milk, okay, milk will be a liquid in form. But when it undergoes oxidation, when it reacts with the oxygen, okay, if you don't heat it for a longer, if you don't boil properly the milk, it forms a curdy like substance, okay. It forms a curdy like appearance. So there will be change in the state of the substance, so like this. So you understand that a chemical reaction or a chemical change has been taken place. So first is what? Change in color of the substance. Second is change in the state of the substance. State means solid, okay, solid, okay, you know what is solid. Solid, then liquid, okay, then gaseous. So this is when you see there is a change in the state of the substance, that means some chemical change has been occurred. Then next is change in heat energy. Change in heat energy, that is absorption of energy or release of energy. So if there is some change of energy, okay, for example, if what is there? Coal is there, okay. For example, coal is there and you have burned the coal, okay, burn the coal. So what will happen? Coal, when it will release, so it will burn, okay. How it will burn? If you burn a paper also, if you burn a paper, what it will do? It will release heat, okay, or wood, coal, paper. So when you burn the, okay, so what it forms? It will release heat in the form of energy, okay. So this is so whenever there is a change in heat energy, okay, either it will absorption of energy means it will take energy, it will take the heat or release some energy. So whenever these are the it means there is some chemical change which is occurring, okay. Then next is release of gas, okay. If there is some release of gas, so if there is release of gas, if some reaction is occurring, okay, for example a vehicle, okay, vehicle, it gets burnt, okay, it get burnt or it gets fire. So what will happen? So more smoke will be released, right? So means what? There is something which is occurring, that is some chemical reaction is taking place. So there is a release of gas, okay. So some chemical reaction has been taken place. So this is a so these are the some of the change in physical and chemical properties, which shows that there is chemical and chemical reaction which is taking place. Now, evolution of light and sound. Evolution of light and sound. Okay, so this is also another this okay property which tells you that chemical reaction is in taken place. So what is the example? So you can see the example. What is the example? So example is given as burning of coal. Okay, I have told you burning of coal or wood. Okay, when you heat coal or wood, so what will happen during the burning of coal? Coal will be solid state, right? It will be in solid state. So this coal, what will happen? It burns. It burns and it will release what? It will release heat and gas, and it turns into ash, right? It turns into ash form. So there will be, so the coal, it changes its state. Okay, it changes its state. There will be release of heat energy. There will be release of gas. Okay, and there will be change in the state of the substance. So these are the properties which tells you that chemical reactions take place. Okay, so these are some of the properties. So remember, so what you need to remember, what is chemical reaction? Okay, what is chemical reaction? So it is a process in which new substance is formed with new chemical and physical properties. So it is said to be chemical change or chemical reactions. Okay, so chemical reaction, what it involves? It involves the change in physical as well as the chemical properties. So which are the properties which tells you that there is a chemical reaction taking place? So first is change in color of the substance. Second is change in state of the substance. Third is change in heat energy. Okay, either absorption or release of energy. Then release of energy, release of gas, and evolution of light and sound. So these are some of the properties which tells you that chemical reactions is taking place. Now we'll see how to write the chemical equations. Okay, how to write the chemical equations. So we have seen. So these were some of the examples, right? So these were some of the examples. Okay, where you could see that the identity of the initial substance have somehow changed, right? So initially the identity was different, and finally after undergoing chemical reaction, the identity of this has been changed. Okay, so so how it is changing? It is due to the physical and the chemical properties which is occurring during this chemical change. Okay, so whenever the chemical change takes place, so whenever there is a chemical change, means there will be change in color, change in state, okay, change in energy, release of gas. That means what? So whenever any chemical change takes place, that means we say that chemical reactions has occurred, okay, or chemical reaction has taken place. So whenever you see any chemical change, okay, whenever you see any chemical change is occurred, that means a chemical reaction has been taken place. Okay, so then, so how do you write the chemical equations? So we'll start. So this chemical reactions we have seen. Now we'll see how do you write the chemical equation. What do you mean by chemical equation now? So the symbolic representation. Now how you write? Okay, the way you write, the way you represent. Okay, the symbolic representation of a chemical reaction is called chemical equation. So whenever you write, okay, you write the symbolic representation of a chemical reaction, it is said to be what? It is said to be a chemical equation. So whenever you represent, okay, whenever you represent, now we are saying in words, right? Chemical reaction has occurred. So how to represent it? You have to represent, right? So the symbolic representation, the way you represent any chemical reaction is said to be a chemical equation. Equation means what? Mathematical equations, you know, x plus y giving you z, right? So there is some chemical equation. So whenever you are representing any chemical reaction in a form of a symbolic representation, okay, in a form of systematic symbolic representation, when you represent your chemical reaction is called as a chemical equation. Now, see, for example, a magnesium ribbon will be there. So if you take a magnesium ribbon and if you burn it in the oxygen, okay, if you burn it with oxygen, now magnesium, okay, Mg, magnesium, when it burns with the oxygen, it gets converted into what? If it reacts magnesium with oxygen, it forms magnesium oxide. Okay, it forms magnesium oxide. So this we are telling in words. Okay, we are telling in words. We need to write in the form of mathematical equation, or we want to write it in the symbolic representation. So we know that what magnesium ribbon is there. So it is reacting with oxygen to form a magnesium oxide. Now, how to write this in the form of a chemical equation? So this description of chemical reaction, it is in the form of a sentence is long. Okay, so I'm telling what magnesium ribbon reacts with what reacts with oxygen to form magnesium oxide. So the sentence seems to be a long one, right? So chemical equations, it on the other side, it is a short form. Okay, it is a simplest way. Okay, it is a simplest way, or it can be written in the shorter way, shorter form. Okay, so whenever you are giving a description, the description seems to be in a longer way or longer form, and the what is it? Equations. Okay, the symbolic representation, it is in the shorter form. So whenever you are writing chemical equation, so it gives you a better sense than your description part. Okay, description means you are telling in this form of sentence. Okay, and symbolic representation means in the form of a equation. So equations will be shorter as compared to the description. So so the simplest way to do this is to write it in the form of a word equation. Okay, now if I want to write, now I'll first write it for the magnesium. Okay, then we'll see what are the steps, how to write it. Now I have given you example, right? I have given you the example. Just a second. Yes. So now what did I say? Magnesium, right? Magnesium. It reacts with what? It reacts with oxygen. Okay, how we write it? Magnesium reacts with oxygen, giving you what? Magnesium oxide. Okay, so this is the shorter form. So this is a way of writing the chemical equation. Now, how to write? Okay, what are the steps? Okay, what are the steps of writing this chemical equations? Okay, so the substances that undergo the chemical change in the reaction. Okay, now whenever you have, so you can see here. So I'll just go. So this is the okay. So in a chemical equation, so I had given you example. Now we'll see the steps of writing the chemical equation. So in a chemical reaction, the reactants are written. So I had given you example of magnesium. Why did I write that? Okay, here. So this was the example, magnesium plus oxygen plus giving you magnesium oxide. Now here you can see. So the first point, we'll go to the first point. In a chemical reaction, did you understand till here? First you clear me that, then we'll go for the how to write the this. Did you understand till here? Yes, Panchami and Shreya.
Yes, ma'am. Yes, ma'am.
Yes. Did you understand? Yes. Shall we proceed? Or I need to explain anything? Yes. Panchami. Okay. So we'll see with the steps. Okay. So I have written magnesium plus oxygen giving you magnesium oxide. So first point, in a chemical reaction, the reactants are written on the left hand side and the products are written on the right hand side. Okay, of the equation. So so this is the first this. So which is the left hand side? So these are said to be, okay, these are said to be what? These are said to be, so these are said to be reactants. What they are said to be? Okay, these are said to be reactants. Okay, so left hand side. So in a chemical reaction, so this is a chemical reaction. So the reactants are written on the left hand side, and the products are written on the right hand side. So this is called as what? This is called as product. Okay. So you have to make the notes, make a short points so that you will remember it. Okay, so whenever you are writing a chemical reaction, so always the reactants are on the left hand side, LHS. Okay, LHS, what is present? LHS, what is present? Reactants are present, and on the RHS, products are on the RHS. Okay, so reactants are written on the LHS and products are present on the RHS. So this is the first point. Now, second point. And arrow. Okay, so this is an arrow which is pointing towards the product is inserted between the reactants and products. Okay, so what it is showing you? Yes, what the reactants and products. So what is the arrow showing you here? So here the arrow, you can see this arrow. Okay, so this arrow, it tells you that magnesium and oxygen, okay, it follows the direction of the reaction. Means what? Oxygen and magnesium, they are reacting you to give you the magnesium oxide. So it is going in the direction of the reaction. So this arrow, it is pointing towards, always towards the products. Okay, so the arrow which is what it always points towards the products which is inserted between the reactants and the products. So what it represents? It represents the direction of reaction. It represents what? It represents the direction of the reaction. Okay, remember this. So what it represents? It represents the direction of reaction. So it always represents the direction of reaction. Now, a single arrow. Okay, a single arrow indicates the direction in which the reaction proceeds. So this single arrow, whenever there is a single arrow in between, it shows that it is going in the direction of the products. Okay, it represents the direction of reaction. Okay, so this is the next point. So whenever there is a single row arrow, it indicates the direction in which the reaction proceeds. If you have a double arrow means like this. I'll write it here. Okay, double arrow. See. Okay, this is double arrow. So a double arrow, what it indicates? It indicates a reversible reaction. So it indicates what? It indicates the reversible reaction. Means what? The products may all again recombine. Means what? Now magnesium, it reacts with oxygen, giving you magnesium oxide. Again, this magnesium oxide can recombine to give you reactants. It can give you back the reactants. Okay, double arrow. Now, whenever this single arrow is there, that means what? That is magnesium and oxygen, it is giving you magnesium oxide. Okay, it will not give you back the reactant. Whenever the single reactant, it will not give a reversible means what? You will get the reactant back. Okay, reversible means you will get the reactant back. Okay, you will get the reactant back. And irreversible means so it will proceed in the single. So whenever you have a single arrow, that means it is proceeding in the direction of reaction. Whenever you have a double arrow, that is a reversible reaction arrow, that means the products are recombining. Okay, they will recombine to form you again. You can get back the reactants. So so this is the meaning of the double arrow. Okay, it is the meaning of the double arrow. Now, a plus sign. Next is a plus sign is inserted between two or more reactants or product formed. Okay, so whenever the plus sign is there, plus sign indicates what? The two or more reactants or product are formed. Okay, so here plus sign indicates that these are combining. Okay, and here plus sign indicates mean that many products or reactants are formed. Okay, that many products recombine to form the product. So whenever you have a plus side which is inserted between two or more reactants or product which is formed, so always the plus sign. So plus sign is inserted between two or more reactants or product. So you can see in between the reactants also plus sign is there. In some time during the with the products also plus sign will be there. Okay, so plus sign will indicate between two or more reactant or product which is formed. Next, if reactions are carried out under specific conditions of temperature, pressure, catalyst, then these conditions are mentioned on the arrow. Now, now some specifications. Now any reaction is occurring and there is some specifications which are means what? Suppose now water. Okay, you know water. Okay, water, if you're boiling at 100 degrees Celsius, okay, water, okay, when you're boiling at 100 degrees Celsius, so you're mentioning the temperature, right? You're mentioning the temperature. So like this, so whenever any reaction is occurring, okay, so the specific conditions of temperature, pressure, catalyst will be written on this arrow. Okay, it will be written on this arrow. So these conditions are mentioned always on the arrow. Okay, so this is about your okay, this is about your point. Okay, so understood. So first is what? Always the reactants are written on the LHS. So first, so till here, whatever we have studied, we'll glance once, then we'll proceed further. So whenever you are writing the chemical reaction, okay, so the reactants are always written on the left hand side and the products are always written on the right hand side. Okay, so this is the first point you have to remember. Second is what? Whenever you have a single arrow, okay, like this single arrow, it is inserted between the reactants and products. Okay, this is reactants and products. The single arrow is inserted between them, and what it represents? It represents the direction of the reaction. It represents the direction of the reaction in which it is going on. Okay, then so this is clear. Now next is double arrow. So whenever you have a double arrow indicates the reversible reaction. Means what? Whatever the reactants are there, they will give you products. Okay. So this will give you reactants will give you products. Products will not give you back. Okay. So this is cancel. Product will not give you reactants when you have a single. But when you have a double, okay, that is reversible reaction, reactants will give you products as well as product can give you reactants back. Okay, so they will recombine. Okay, they may recombine to form the products reactants back. Okay, so whenever you have a double arrow, this is called as double arrow. Then next is what? Plus sign. So plus sign, what it indicates? Plus sign is inserted between two or more reactants or product which is formed. Okay, so whenever the plus sign is there, so it is inserted between two or more reactants or product which is formed. Okay, then so whenever any specification and whenever your reactions are carried out with some specific conditions like temperature, pressure, catalyst, then these conditions are mentioned on the arrow. Okay, then these conditions are mentioned on the arrow. So this is the next point. Okay, then next, chemical equation can be made more informative by mentioning the physical states of the reactants and product. Physical states are always mentioned like this. For example, okay, now this is one example of a reaction. Now this is one example of a reaction. Okay, now this is a reaction. So this is a chemical reaction. Now what is this? This is a reactant. Okay, this is a product. Now what did I say? So the chemical reactions can be made more informative by mentioning the physical state. Physical states means like this. Now calcium will be in solid state. Okay, gaseous, solid, and calcium oxide, solid. So like this. Okay, so this is by mentioning the physical states of the reactants and products. Okay, so whenever you are writing the physical state of the reactants and product, you are giving more specific information of the chemical reaction. Now, if the gas is liberated as a product, then it is represented by arrow pointing upwards. Okay, so whenever any gas, okay, suppose Zn plus H2SO4 giving you ZnSO4 plus H2. H2 is a hydrogen gas. So this hydrogen gas, okay, it is liberated. Liberated means it will escape out. Okay. So whenever now zinc, okay, now suppose zinc zinc plus H2SO4. Suppose zinc plus H2SO4, it is reacting to give you what? ZnSO4, that is zinc sulfate. Okay, plus H2. This H2 is what? H2 gas. So whenever this reaction occurs, H2 gas will be liberated or it will be escaped. Okay, it will go in the air. So that is always the gas. So whenever the gas is liberated as a product, then it is represented by pointing the arrow upwards. So you can represent it by pointing the arrow upwards. Okay, so this is the next point. Now, the next point is what? If the product formed in the form of precipitate. Now, this is what Zn plus H2SO4. Okay, Zn sulfate, this is a product which is formed as a precipitate. Precipitate means what? It will be like a curdy form. Curds, you know, curds. So it will be like a curdy form, precipitate. Okay. So whenever a product which is formed in the form of a precipitate, then it is represented by arrow which is pointing downward. So like this, precipitate means it will be forming a precipitate. Okay, like a curd form. So it will form a precipitate. So always it will be represented by pointing the downwards. Okay, the arrow downwards. So upwards means what? Whenever the arrow is upward means the gas has been escaped or gas has been released. Okay, and downwards means the product which is formed of a precipitate. Okay, when it is forming a precipitate, then you're putting the arrow downwards. Okay, so this is about your understood till here. Understood? Yes. Any doubts you can ask, then I'll proceed further. So so these are the steps. The steps are clear. Yes, Shreya. The steps are clear. Clear. Whatever has been taught. How to write the chemical equations. What are the different steps? Okay, so next we'll go for balancing the chemical equations. Okay, what do you mean by balancing? Balancing means what? Now, what do you mean by balancing? Can you tell me example? What do you mean by balancing? Now, when you're playing seesaw, right? When you're playing seesaw, the person who is sitting here should be equal to the person who is sitting here. Okay, so if so, right. So, you know, in seesaw, the persons who are sitting opposite to each other, they should be of same mass or same weight, right? If one person is lean and another person is hefty, the person with the lean, he will go up, right? He will go up. So always balancing is important, right? So whenever you're writing the chemical equations also, so what we see that the chemical reaction is balanced, means both the reactants. Now you know what are reactants and what are products. So we'll be discussing. So we'll use that words now. So henceforth we'll be discussing those words. So whichever is on the left hand side, it is called as reactants. So whatever is on the right hand side, it is called of the products. So across the arrow, whichever is on the left hand side, it is what? Reactants, and on the right hand side, it is products, right? So, so always across the reactants and products, the number of element, okay, they should have a proper, the number of reactants and the number of products should be equal. So, what is balancing the chemical equations according to law of conservation of mass? Okay. So the total mass of the reactants and the products should be equal. Okay. So the total mass of the reactants and the product should be equal. So in order to maintain the law through, it is necessary to balance the chemical equation. So always, so what is the mass of conservation of mass? What is the law of conservation of mass? That the total number of mass across the reactants and the product should be equal. Okay. So in order to maintain this law, it is always necessary to balance the chemical equations. Okay. So what are the steps which are involved in balancing the chemical equations? So what are the steps? So first is determining the reactants and product in the reaction. Okay, the first step is what? Determining the step of a. So step is first is to determine the this, just a second. So determining the reactants and products in the reaction. So so whenever you are writing the chemical reaction, first step is you have to tell which is reactant, which is the product in the reaction. So on the left hand side it is called as the reactant, and on the right hand side it is called as the product. So first step is you have to determine which is reactant and which are the products. So this is the first point. Second point is what? You have to count the number of atoms of each element on both sides of the equation. So what is the next step? You have to count. So for example, zinc. Okay, Zn plus H2SO4 giving you what? ZnSO4 plus H2. So if this is an example, so what you have to do, you have to count the number of atoms of each element. Now this is zinc is one element, hydrogen is one element, sulfur is one element, oxygen is one element, right? So you have to count. So this is a reactant, this is a product. So what is our step? You have to count for the number of atoms. Okay, number of atoms. Now, for example, here zinc. For example, now zinc. I'll just take another color. Okay. So for example, zinc. The number of atoms of zinc is how many? 1. Right. 1 here. Just a second. Okay. So 1, and here. So here 1. Right. This is 1. 1. Right. Then hydrogen. You can see hydrogen. Hydrogen atoms are how many? 2 hydrogen atoms are there here. Right. Here hydrogen atoms are 2. Right. Then sulfur is here 1. Here sulfur is 1. Then oxygen atoms are 4. Here oxygen atoms are 4. So you have to count for the number of atoms of each element on both sides of the equation. So this is the second point. So second point is what? You have to count the number of atoms of each element on both the sides of the equation. Now, selecting the element that occur for least number of times in the equation. So select the elements that occur for the least number of times in the equation. Okay, balance the atom for each element on both sides of the equation. So whenever if the equation is not balanced, so you have to select the element which is occurring for the least number of times in the equation. Okay. Then you have to balance the atoms of each element on both the side of the reaction. So after seeing the atoms across the side, if it is not balanced, then you have to balance on both the side. Okay. Then always leave hydrogen and oxygen for last to balance. So whenever you have hydrogen and oxygen in the reaction, so don't go to balance it at the first, you have to balance it at the last. Then balance the hydrogen atoms lastly, followed by balancing the oxygen atoms. So always balance the hydrogen atoms at the last and then the oxygen. So first you have to balance the other elements, then you have to go to balance the oxygen and hydrogen. Okay. So we'll see one example. After seeing an example only you'll come to know. So this is the unbalanced equation. So formation of ammonia. Okay, formation of ammonia. Ammonia is N2. N2 is nitrogen, H2 is hydrogen. So it is giving you NH3. So for what is first step? First step is you have to count the number of atoms of element, right? First step is to count the number of atoms of element. So how many atoms are there across the reactant? So there are two nitrogen atoms, right? There are two hydrogen atoms across the reactants. Okay. Then across the product. Okay. So this is the product across this single bond. So this is product. So count for products. So that is one nitrogen and three hydrogen atoms. Okay. Then second step is what? In the above equation, the number of nitrogen atom, is it balanced? Here nitrogen are 2, here it is 1. Hydrogen is 2, this is 3. So it is unbalanced, right? So in the above equation, the number of nitrogen atoms on both the sides are not equal. So what you have to do? You have to multiply it with a suitable integer, okay, to balance the nitrogen atoms on both the sides. So you have to see, you have to balance the equation in such a way that you have to multiply it with a suitable integer. Okay, so if we multiply, now here how many we want? Here the number of, this is 2, here it is 1, here it is 3, here it is 2. So if you multiply it by 2, okay, if you multiply here the on the right hand side by 2, you will get N2 plus H2 giving you 2NH3. So now you see N2 is 2, nitrogen is 2, hydrogen is 2, nitrogen is 2, and this, what is that? Hydrogen is here 6. Yes, 6. Now, at last, what you have to balance? At last, you have to balance your hydrogens, right? At last, you have to balance your hydrogen. So whenever hydrogens and this is there, okay, oxygens are there, that you have to balance at the last. So I'll tell you this again in the next class, but now we'll see, this will complete it. So then hydrogen atom, so what we did? So N2 plus H2 was there. We multiplied it at the right hand side by 2. So number of nitrogen 2, hydrogen 2, nitrogen 2, hydrogen is 6. At last, we have to balance the number of hydrogen by 6. So if you multiply this by, so your hydrogen atoms on both the sides are not balanced. So what you have to do? You have to multiply this by 3, hydrogen by 3. So 3 2s are 6, right? So multiply with, so now you can see the, it is balanced. The chemical reaction is balanced. Understood? We'll solve 2-3 examples in the next class. So if you solve as many number of examples, that much it will be clear. So today you have what you have to do? You have to read the definitions. Okay, what is chemical equations? What are the steps? So next class, first 5 minutes we'll be revising. Okay, first 5 minutes we'll be revising. What are the steps? How to write the chemical equation? Okay. Then you will be telling me how to balance the chemical equation. Okay. So to next class, I'll get some more examples on how to balance the chemical equations. Then we'll, so that your whatever doubts will be there, or you will be more clear. Okay. It will be more clearer for you. Okay. So understood till here. Okay. Balance chemical equations. Some more examples, if I solve, it will be more clear for you. Okay. So understood what is balancing the chemical equation. Balancing means what? On either side of the reactants and product, that is across the single bond, the number of reactants and products should be equal. The total mass. Okay. So it should be equal. Okay. So this is about chemical reactions and equations. So we'll meet in the next class. Okay. Thank you, students. If you have any doubts, you can ask me, or you can leave the